This video will walk you through how to solve radical equations and also equations with fractional exponents. So this is going to correspond to the last lesson in Unit 7. So made up a few different examples here so you can try the ones in your notes and see if they match up based on what I'm showing here in the video. So there's basically three things we're going to go over here. How to undo problems that have different roots, how to undo problems that have fractional exponents, and then also look at problems that have square roots and look for extraneous solutions. So let's look at the first example here. We have the fourth root of x plus 7 equals 5. I have nothing on the left side except everything crammed under a root. So I want to undo the root by taking its reciprocal power. So by having a fourth root, to undo it, I'm going to take a fourth power. And I'll do that to each side. Fourth root and the fourth power cancel, so I'm left with x plus 7 equals 5 to the fourth power, which is 625. Subtract 7 from both sides, x will equal 618. Now, some of these problems you will get some slightly bigger answers than maybe what you're used to, but ultimately you get what you get. If you're not sure of what you got, plug it back into the problem, see if it works. The second equation is very similar. I have the cubed root of 6x equals negative 6. I want to undo the cubed root by taking a cube of each side. So that will leave me with 6x equals negative 6 to the third power is negative 216. Keep in mind, with an odd-numbered power, your answers, if you have originally a negative base, the answer will also remain negative. To get x by itself, simply divide by 6. X would equal negative 36. And again, you can plug that back into the original problem, and you'll see that both sides will indeed equal out. Now, let's take a look here when we have fractional exponents. So here in number 3, we have x to the 2/5 plus 18 equals 22. Before I even worry about the fractional exponent, I see something being added, and as we know with how to solve equations, first thing we want to look for is, can I get rid of addition or subtraction? Let's move the 18 subtracted away, so I'll have x to the 2/5 power equals 4. When I have a fractional exponent, the way to get rid of it is to take the fractional exponent to its reciprocal power, meaning I'm going to take the 2/5 and raise it to the 5/2. Knowing exponent properties, when I have power to a power like I see here on the left side, 2/5 to the 5/2, those will multiply together to become 10 over 10. It cancels out to a power of 1. Ultimately, I need to do that to get the x quote-unquote unlocked. Now, the other detail we're going to need to keep in mind, especially with fractional exponents, is just like with roots. If you remember in the beginning of the chapter, if you take an even-numbered root in an equation, so taking a square root, a fourth root, a sixth root, etc., you need a plus-minus sign when you solve. With fractional exponents, keep in mind, fractional exponents are just another way to write radicals, another way to write roots. You got to look at the denominator. If your denominator is even, like it is in this case, you're going to need a plus-minus whenever you evaluate your problem. So the fact that we're taking the 5/2 power of each side, the denominator of my exponent is a 2. That's an even-numbered square root. So you can punch 4 to the 5/2 power in your calculator. It'll spit out 32. But what you need to keep in mind is that you need the plus-minus sign to go with it, because there are technically 2 answers that will satisfy this equation. If you're not sure that that's the case, again, you can plug both of them in to check your math. But that is a little detail you're going to need to keep in mind. Number 4 is pretty much the same idea, except there's less to move. Everything is locked in parentheses with a power, so I'm going to undo the power by taking a fractional exponent, the reciprocal power to each side. So I see 3/4. I'm going to raise each side to the 4/3 power. That'll get the x minus 4 by itself. Now, since my denominator is odd, no plus minus in this case, because it's an odd root, we don't have to worry about that. So you could just punch in 343 to the 4/3 power and not worry at all about remembering that pesky plus minus, because the denominator is odd, the root is odd. 343 to the 4/3 power comes out to 2401. Add 4 to each side, you will get x equals 2405. So there we have a couple of examples of undoing a root. Here we have a couple of examples of undoing a fractional exponent. And now we're going to take a look at with square roots, with the focus being on checking for extraneous solutions. Because oftentimes with these square root problems, this is where you might see solutions that work out at first, but you plug them back in and they don't technically work within the problem. So here in 5, we have x equals the square root of 6x plus 27. I need to get that square root to go away. So keep in mind it's a second root. So to undo a square root, we're going to square each side. That'll give me x squared on the left side. The right side will leave me with just a 6x and a 27. Now, in this type of problem here, we see two different types of x's, the x squared and the x term. This is going to be a signal that this is going to be a problem that we need to factor apart. So in order to do that, we need to get this equal to 0. So I'm going to move over the 6x by subtraction and the 27. And I'm going to get everything to one side because that will set this up so that it can be easily factored. So here we have a simple trinomial. We need to figure out what multiplies to negative 27 adds to negative 6. The two values that will do that are negative 9 and positive 3. Just like always, we take each factor, set it equal to 0. It gives me two possible solutions, 9 and negative 3. Now, in problems like this, especially problems where you have two answers, you probably want to be diligent in checking to make sure that both of them work. Sometimes both will work, but sometimes only one of them will. So, really quick here, not saying that you have to show this workout necessarily, but at least knowing how you would plug this into your calculator. Let's say I plug in 9. So we're going to check this stuff out here. I'm going to plug 9 into the problem. So I'll have 9 equals the square root of 6 times 9 plus 27. 6 times 9 plus 27 is 81. Square root of 81 is 9. 9 equals 9. So 9 is a good answer. Now I'm going to do the same thing with the negative 3. So negative 3 equals the square root of 6 times negative 3 plus 27. That'll give me negative 3 equals the square root of 9. That leaves me with an issue here. So the problem is I can't have the square root of a number equal solely a negative. That's not going to work itself out. These two answers don't, that particular answer in negative 3 doesn't quite work. So 9 is the correct answer. Negative 3 would be considered to be extraneous. Therefore, we only have one correct answer in this case. So you do want to check to make sure both answers actually work. Doesn't mean the negatives always fail. Typically, that's where you'll find a mistake, but that's not always going to be the case. Make sure you check to see that all of your answers actually do work, whether you write it out or plug it into your calculator. So we'll see kind of the same thing here in number 6, but we'll, again, check to make sure everything's right once we actually figure out what our solutions will be. So, same thing here. I've got a square root on the right side here. I'm going to need to clear it. So, the biggest thing you want to make sure of, so on the left side I have an expression. I have n minus 2. It's not just n. I need to make sure that I write that n minus 2 twice. You cannot distribute the squared to each term. That's not mathematically correct. You'll end up missing a couple of terms. So we're going to write it out twice to make sure everything's affected correctly. So we'll take the n minus 2, multiply it with each other, and then with n squared minus 4n plus 4 equals 5n minus 14. Combine some like terms. Excuse me, let me backtrack here a second. I realized I wrote 4n's. I should have been writing 2n. Let's fix that up here. Always be careful with your details. So now we're going to combine like terms correctly this time. Now, again, I see two different types of n's, so I'm going to swing everything over to the left side, set it equal to 0. So I'll have n squared, subtract the 5n over, it'll combine with the negative 4n, give me negative 9n. I'll add the 14, that'll give me positive 18. So n squared minus 9n plus 18 equals 0. So what I'm going to do from here is go through and figure out how does this factor apart. So this will become n minus 3, n minus 6. Negative 3 times negative 6 is positive 18. Negative 3 plus negative 6 is negative 9. That gives me two values for n, 3 and 6. So now that I have those values, I'm going to take a quick check and make sure this stuff actually works. So I'm going to plug 3 in first to the original problem. So 3 minus 2 equals square root of 5 times 3 minus 14. 3 minus 2 is 1, equals square root of, that ends up being 1 underneath. 1 equals 1, that's good. Now I'll do the same thing with 6. Plug that in. So on the left side I get 4, Underneath the radical, I'll get 16. Square root of 16 comes out to 4. 4 equals 4. That's good to go. That means both of these answers are good, and both will work in this problem. So, in short, you've got a few different types of ways that you're going to be solving for answers here dealing with radicals and fractional exponents. A lot of it is, again, just taking reciprocals of everything. If you have a root, take that version of it to a power. If you have an exponent, that's a fraction, flip it around, take the reciprocal of it to each side. When you see problems with square roots especially, be on the lookout for those possible extraneous solutions. And again, check to make sure that your answers do indeed work. And that's how you go about solving radical equations.